Okay, I'm going to work a few more of these homework problems in case you need some help with them. Now, we were talking about our strategies. Here's another one here. If I look, I've got two terms on the first left-hand side of this, and I see that I'm going to turn it into one term. So a lot of times when I've got like two terms over here, and I see one term over here, I usually try to get a common denominator unless there's something else really obvious to do here, and I don't really see anything that's all that obvious. I could turn sine squared into 1 minus cosine squared theta on the top, but that's just a bigger mess. So here's what I'm going to do. I'm going to take 1 minus sine squared theta over 1 minus cosine theta, just cosine theta. And let me get a common denominator. Now the denominator over here is 1 minus cosine theta, so I can multiply this 1 by, remember if I'm multiplying to get a common denominator, I got to multiply the top and the bottom, and that will be times 1 minus cosine theta. You can't read that. Let me do it on the next line. 1 minus cosine theta. If I multiply that by 1, I'm just going to get the same thing back. Remember, I am not adding and subtracting things from both sides of that top equation. I am just taking the left side and trying to make it look like the right side. Don't do it. Okay, so what this gives me, if you look, is just 1 minus cosine theta over 1 minus cosine theta times 1 is just 1 minus cosine theta over 1 minus cosine theta. But now I've got a common denominator. If you remember when we have a common denominator, you can just put the two terms over that one fraction. It's like 1/5 plus 2/5 is 3/5. I just would keep the 5 on the bottom. Well, here I've got 1 minus cosine theta on the bottom. And so that's minus sine squared theta. Okay, so got this far, got a common denominator. Let's see if there's anything we can do here now. Okay, now there is something I could do here. I'm going to decide, since I've got so many cosines, I think what I'm going to do is change this sine squared into cosines. Remember that you've got the identity sine squared theta plus cosine squared theta is 1. So if I manipulate that, let me kind of write down what I already have. I already am going to keep up with my 1 minus cosine theta. And on my denominator, I have my 1 minus cosine theta. But I'm going to rewrite sine squared theta. I'll write it in red just so you can see that's what I replaced it with. Minus, okay, sine squared theta would be 1 minus cosine squared theta. All right. Now I got to distribute that negative sign. So that's 1 minus cosine theta, and then minus 1 plus cosine squared theta over 1 minus cosine theta. Okay, now the 1 minus 1 is going to go away, so I'm going to end up with minus cosine theta plus cosine squared theta. I'm going to go ahead and write the cosine squared theta first, just because I like having the positive term first too. So I have this now. Okay, so I don't know what to do, so let me just try factoring out a cosine theta. Okay, so if I take a cosine theta out of that, that would be cosine theta minus 1 over 1 minus cosine theta. Now, if you remember, those don't look alike, but I can make them look alike. On the bottom, if I want to turn the bottom into cosine theta minus 1, that's what I'll do. I could factor out a negative, and that would be negative 1 plus cosine theta, okay, which would be cosine theta times cosine theta minus 1 over minus cosine theta minus 1. Okay. So remember, if you've got two things and they're subtracted and they're like swapped, that's what you can do is factor a negative out. So now these would cancel out, and I would just be left with cosine theta. And remember, you could write a 1 here and here over negative 1, which is negative cosine theta. Okay, on 55, they tell us to factor the expression and use the identities to simplify. So I know I got to do factoring here. I don't know if you remember this or not, but let's say I had this problem is similar to this problem. What if I had x to the 4th plus 2x squared plus 1. I would have factored that. I would say, okay, what multiplies to give me 1 and adds to give me 2? Well, 1 and 1. And instead of putting an x here and an x here, I could have tweaked that and put a square here and a square here, and I would have factored that problem. That's what I'm going to do here. I've got, remember, this tangent to the fourth x could be thought of as tangent x to the fourth plus 2 tangent x squared plus 1. So that will factor. Let me make my little factoring parentheses. Instead of an x in here to the fourth power, I have a tangent x to the fourth power, so that's just going to become tangent squared x, and tangent squared x. If you think about it, that would give me that tangent fourth x back. And then if I think about this problem being a lot like this one over here, 1 times 1 is 1, and if you look at your middle terms, let me put a plus here, this would be 1 tangent squared x plus another tangent squared x would give me 2 tangent squared x. Sometimes what we do is, you could think of this as, well, we can talk more about this in class. We've done stuff like this before. I just want you to notice it's a similar thing, okay? Now, do I have an identity that tells me what tangent squared plus x is plus 1 is? It looks an awful like it might be a Pythagorean identity. And if I go check and look, what we do know about tangent squared x and 1, and again, I knew to think that because there was a square term and there was a 1. Actually, tangent squared x plus 1 is equal to secant squared x, okay? So this one is just secant squared x, and the other one is secant squared x, and so this is equal to secant 4x, or you could write it as secant x to the fourth power. Either way, you could simplify those three terms down into this. In calculus, that's going to be great because it's going to help us use differentiation and integrals to solve problems if we can rewrite it much simpler. So either way, I'll just circle that one as the answer. Just going to try to squeeze what I can onto this video. We can look at 57. We have sine fourth x minus cosine to the fourth x. I see, couldn't I write this? This looks like a difference of two squares thing. Couldn't I have sine x squared would be sine to the fourth x minus cosine x squared. I could look at this as, remember your difference of two squared factoring pattern is a squared minus b squared factors into a minus b, a plus b. Again, it doesn't matter whether you put the plus or the minus first. So this would be sine x squared minus cosine x squared. And the first factor, because your a is this sine squared x and your b is this cosine x squared. Let me put the square out here. And then it would be those two things added together, sine squared x plus cosine squared x. Remember, on one of these, I'm just using both of those. I could have written them both that way. Let me just show you. Some people like to write them different ways. Okay, so this is sine squared x minus cosine squared x times sine squared x plus cosine squared x. Remember that these two are just different ways of writing the same thing. Now, I know that sine squared x plus cosine squared x, which is what I have right here, is equal to 1. That's a Pythagorean identity. So I've got sine squared x minus cosine squared x, and then I can replace that second parentheses with just 1. Okay? So now I'm down to sine squared x minus cosine squared x. Oh, but that factors. That factors into sine x. That's the difference of two squares too. I could keep factoring. That would be sine x minus cosine x times sine x plus cosine x. Honestly, I would think stopping here would be good. Just knowing how we would do this in calculus, this is a good place to stop, though it would factor down into this other expression here. And if we factored it all the way, you would end up here where this second check mark I'm putting is. But in calculus, we probably would have stopped right at that step there, even though it would factor further. It would just be easier to deal with it in that form. But I bet the book's going to write this as the answer, that last thing. 59 is factoring by grouping, which you haven't maybe seen in a while. When you have 4 terms, if you remember, you can group 2 terms and 2 terms together. Okay, so when we factor by grouping, and that's what they're telling me to do here is to factor. I'm going to put these 2 terms together. I'm going to put these 2 terms together, and I'll just kind of color code so you can see where I'm getting stuff. Out of the first 2 terms, I could factor out a cosecant squared of x. And remember, that's my GCF, and what would be left would be cosecant x minus 1. Okay? Now, if you look down here, there's not anything that divides out a cosecant x plus 1, but I don't know if you remember this. When you factor by grouping and you had a subtraction sign right here, you always factored out a negative, and we'll call it a negative 1 since there's nothing else we'll divide out of it. If I don't do that, it's going to look kind of weird, and I'll have to add that 1 in anyway. If I factor out of a negative, that's cosecant x minus 1. If you want to make sure you got the right thing, try this, distribute, and see if you got it right. Negative 1 times cosecant x is negative cosecant x. Negative 1 times negative 1 is plus 1. I got it right, didn't I? Okay. Now, in factoring by grouping, what you want to have happen is these 2 parentheses be the same thing, and they are here. So since they're the same, I basically had 2 sets of terms I took GCFs out of. Now I'm going to say, oh, look, I got 2 big terms, and each one of those has a GCF of cosecant x minus 1. And what would my leftovers be? My leftovers would be these things that I'm underlining in black, cosecant squared x minus 1. Okay, well, I'm supposed to factor this all the way. This second one over here, and I'll underline it in purple. This one right here is a difference of 2 squares. I could think of it as cosecant x squared minus 1 squared. So that's going to factor into cosecant x minus 1 and cosecant x plus 1. Okay. If you look now, I've got it completely factored. I could say, hey, these 2 things are the same thing, so maybe I would want to write them as a square. You know, I don't have to, but I bet the answer key probably would if I'm guessing. And then you've got this other thing that you're just going to copy down. This would be factored, and that's what they're wanting you to do there.